was about to say morning. I'm here to talk about satellite communication usage in critical infrastructure. I think this is something that we don't really fully understand, and so we just kind of like say, that's scary, that's bad. There's a lot of there was a lot of news and headlines about the wind turbine disruption after the Viasat compromise, but the wind turbines didn't actually stop producing energy. So I think we need to talk a little bit more about like the nuance of like when do data flows just be interrupted and when is it visibility that's interrupted, and that's what I'm going to try to do in this talk. So my name is MJ Manuel. I am on the ICS incident response team at CISA in the threat hunting subdivision, and I do kind of a mix of forensics and threat intelligence. I also will be teaching at the Power Bridge Institute next semester about critical infrastructure and cyber. So, as I said, my goals for this talk are kind of to structure it around an incident response we had earlier this year at CISA for a SATCOM service provider. But I'm really going to be talking more about how data is generated in critical infrastructure and how it flows, because I think we need to understand like what's normal to talk about how can we derive impacts from that. And then consequent-driven impact analysis is really the key to this. So this is something that's really been pushed by INL for the past couple years. If you've heard of CCE, that's cyber-enabled consequence-driven engineering. So it's something that's being talked about when we're talking about how do we design these systems. But I think it's something that we also need to bring about when we're analyzing these systems and thinking about threat intelligence for critical infrastructure. So our incident kicked off just from an outside tip. There was suspicious activity at a telecommunications environment. So we initially attempted to perform victim notification to this telecom provider, and then we quickly realized that the impacted entity wasn't the telecommunications provider, it wasn't the owner of the IP, but it was who they were leasing it to. And who they were leasing it to was the satellite communications provider. I think this was like a perfect, oh no, what did we just get into? Example that kind of highlighted what happened later in this case, because I don't think any of us really can appreciate how convoluted the satellite services industry is. There's been an insane amount of consolidation, an insane amount of mergers that makes it really opaque, and it makes it really hard to drive change because there are so many players on the back end that are never ever interacting with the end users that are subscribing to the services. So just an example, we're going to be talking mostly about Inmarsat BGANs for this talk because that was the type of service that was impacted in the incident that I'm going to talk about. So this is just one of the many different types of satellite services that people can use. And just for this specifically, basically the satellites are owned by Inmarsat. There's basically only 4 of them in the current generation. It runs on the L-band, and basically like any of the data that's flowing is going to go to one of those satellites and then come back down to only 6 ground stations around the world. So something that's always going to happen when you're talking about using satellite services is how does that data flow from one of those 6 access stations back to the end users? Because I think a lot of us kind of think about satellites like radios. We think the data is just going to go up and then down, but that's absolutely not how it happens. And then when that data is in transmission, there's a lot of opportunities for there to be risk. And then there's also just, only 3 terminal manufacturers. So, I'm not really going to talk about this, but when we talk about like supply chain issues, because there's so many vendors in this space, there's just also a lot of opportunity there for there to be risk. So after we initially started talking to the actual entity that was impacted by this incident, we quickly learned that they did have customers in critical infrastructure. So, CISA has both the ICS CERT and US CERT legacy incident response teams. So that means that we're responsible for both critical infrastructure, or really any private sector companies that want to come to us, as well as federal agencies. And I think that kind of gives us a little bit of a bias, because when a federal agency comes to us with an incident, it's very easy to realize that's something we want to resource. But when a random service provider comes to us or we come to them, it's not something that's always like going to be a priority. One of the really big, I will say lively debates about this incident was a lot of people thought that the service that was being provided was just going to be satellite phones, that it was just the phones and just talk communication that was being transmitted by these networks. that was absolutely not the case. So I'm going to talk a little bit about like what is Scada, so we can kind of think about what exactly was being, like what was actually flowing through those environments. So I think, we kind of interchange a lot of terminology like it's all the same, but actually ICS and Scada are not interchangeable. So ICS, Industrial Control Systems, is kind of the larger like bucket of term, and then Scada, Supervisory Control and Data Acquisition, really refers to a specific type. It refers to data, or it refers to systems that are over like a large geographic area. The opposite of that would be a DCS system, a distributed control system, and that's really more like one specific location. So like a DCS is something you might see at like a specific power generation facility, something that like it's local, probably all wired. And then a Scada system might be like power transmission, like lines over like millions of miles, or not millions, but miles of data. And then this communication, it really is up to whoever engineered the system. I've seen people lay fiber, I've seen people use microwave, cellular, satellite. It's really up to whoever designed the system. Okay, and then let's talk a little bit about what kind of data is being generated. So if you look on the right side, these are kind of like the field devices that are gonna be like the lowest level when we talk about like these are done systems. These are just like your temperature sensors, your pressure systems, like maybe a valve that opens or closes. And then the control of that system is going to be from the PLC, the programmer logic controller. So the data is either being, the data is either a command being generated from the operators that are sitting upstream in the corporate, at the control center, and it's being pushed down to the field device, or the data is some sort of temperature sensor, some sort of data that's being read and sent back upstream for the operator to have. So that's the type of data that we're having, both things like maintenance data as well as commands. The commands that change the physical state of those devices on the right. So I kind of want to like drive home that point about that translation between logic and physical change, and I think a really interesting way to do that is the configuration files from Indestroyer 2. So right here is one of the configuration files, or part of a configuration file from Indestroyer, for one of the Indestroyer 2 samples. And I think, Indestroyer 2 isn't that exciting technically, because all it's really doing is pushing commands in a specific protocol, the IEC 104 protocol, which is something mostly used outside of the US in the power sector. But basically what you can do if you try hard enough is you get these numbers, these IOAs, information object addresses, and then if you go back to the vendor documentation, in this case it was ABB, you can start to map the IOAs back to the actual engineering functions that they're referring to. So these numbers that were in the configuration file, you can map here to the data points that describe the engineering function. And then later in the documentation, you can start to translate those back to like what actually is it changing. And so in this case, it was both supervision alarms as well as circuit breaker failure failure protection. Those were the things that were being turned off and on from the configuration file of Indestroyer 2. So I think it's really hard to get to this level of understanding because every SCADA environment is going to be engineered differently. It's not like an HTTP status code that's going to be standardized. And I think this is kind of like the crux of why the field of ICS forensics has so much trouble, is we kind of keep approaching it like it's going to be something standard, like a lot of IT protocols, but it's really going to be, it's not really about like what function codes are being generated. It's about what systems they control at the end, and that's really hard to do. The other thing that I wanted to talk about really quickly, I guess I kind of already said, was just like, I think this is how we think of a lot of data flows happening, like from the specific control center back up and then down to the field, but that it really looks like this. So you almost have at least one kind of third party that's going to be like consolidating those information from the different end users and then sending it to the ground station and then to the satellite and back down. So in the incident that I'm talking about, like this was what was compromised. It was one of those things that's consolidating. I think they had definitely dozens, it might be over 100 customers in a lot of different important sectors. And all of the data was being transmitted through this one entity. So I think, I love to talk about what are the pain points when we talk about critical infrastructure, like what are the things that would have the most impact, and these types of service providers, as well as things like integrators, like the people that are building these systems for their end users, are really, really like sexy targets, and I think we should maybe focus a little bit more on them as we think about like where could the things be the most painful. Then this is like, I had to kind of shorten this part down because I'm going to be well over time if I went into it. But I think, we kind of touched on this yesterday in the fireside chat, but like, I think it's really easy for us as researchers to kind of blame end users for not implementing best practices and even like really basic things like logging. But like, what do we do now when it's 2022 and like, almost no one has logging in place in like actual critical infrastructure entities or even small businesses. And I think it's like time, it's time for us to stop like judging them and just telling them to do it and giving them like additional ways to do it and show them how, because shaming them obviously isn't working. So with the very, very, very limited data we had, like the first thing they gave us was basically just 2 weeks worth of firewall logs. We eventually were able to scrape some older historic logs from some of the backups they had, but we basically had no historic network logging at all for this incident that was multi-month dwell time. So just like in the real world, we can just say analysis happens and then it happens. So the initial findings for this incident honestly weren't that exciting. We were able to trace it back to an unpatched FortiGate that was the FortiGate that both was used for remote employees to like log into the service provider, but it was also the FortiGate that had static routes to all their customers that was the last hop of transmitting all of their Scada traffic. That was really fun. So it was like the CV from 2018 for FortiGate. There's a Metasploit module for it. It's nothing that's hard to do. And what that vulnerability allows you to do is to scrape creds from all of the active sessions that are running on the device. And so all the adversary had to do was move through the environment using those shared admin accounts. And then the other thing that they were able to do when we were interviewing the owners of this network, they kept saying, but those are our backup devices. Like, those are our, like, emergency routes. Like, why is the adversary doing things they're not supposed to be doing? And it's just like, yeah, I mean, it's still connected. Like, it's still, like, they had, like, basically like an out-of-band FortiGate that used the same credentials as the real FortiGate. So yeah, it was really not that hard for the adversary to move around. And then the one thing that we really did see them doing was focusing on just basically information that could give them additional access into the environment. So things like their network management platform or their rancid server or their Radius database. Like, these are all things that we saw them like being very interested into. And then the thing that was the most concerning was that all of their customer traffic was flowing through the environment unencrypted. I kind of thought this was going to be the case, but honestly, I wasn't really sure because I've never looked at a service provider network like this. So let's talk about, like, what does that actually mean if your Scada traffic is flowing unencrypted in an environment? Here are some of the different protocols that we consider to be ICS protocols that we were able to capture because we were tapping for, I think, 3 or 4 months with their permission. And this is a good time to plug that SZA does have some bro parsers for ICS protocols that are on our GitHub. So we are also always taking suggestions for additional protocols. So if any of you guys do ICS monitoring and want something parsed, please talk to me after this. So when we're talking about unencrypted protocols, basically the reason why the traffic was able to move that way was because the traffic was encrypted from like here to here on that FortiGate, and then it was encrypted like here to here, but then it's unencrypted in the middle. So it's like just basic, they weren't using end-to-end encryption, but like when we were interviewing a lot of their end users with the permission of the company, most of them didn't realize that their data was at risk in that way. And this is actually a simplified diagram of how the data was flowing. There was actually like 2 to 3 more hops to different telecommunication providers. And so that means that Scada traffic was at risk at all of those different providers. So this was the point where people started to freak out. But I don't want us to do that yet. I think like Something that is a really large misconception is that for some of these SCADA protocols, you can just like push a function code that says like do bad and it'll blow something up. That's not how it works. So we're gonna talk a little bit about what does it mean if you can do something like read a coil or write a coil. So, going back to the diagram earlier, if you are, at that program logic controller and you're telling a temperature sensor to do something, or you're opening a valve when it shouldn't be, how much additional work does it take for there to be some sort of physical impact? And that's really going to be unique to every case, and I think that's why doing true impact analysis on these systems is so hard. So initial conclusions about the incident: full identity compromise. We're not really going to be able to detect anything else they're doing because there was no logging. The most exciting thing here is that they actually did take PCAP and exfil it on the interface where the customer SCADA traffic was flowing. So we knew that they knew what they had, or they could have known what they had. I'm sure there was other, we don't obviously know exactly why they did that, but in my opinion, I feel like they did understand the value of the data that they had access to. So what are the other potential consequences to that system? And in order to illustrate this point, I'm going to talk about a specific sector which really heavily uses remote connectivity, which is natural gas pipelines. So the main point here is basically the natural gas sector kind of has like three subcomponents. There's production, there's transmission, and there's distribution. And the important part here is that there's often a couple of really key players in the space, like it's very consolidated industry, that does the transmission part. So they're responsible for transmitting gas basically like across state lines, like over long distances. And then they have contracts with the distribution sector. So like the gas that's coming to you locally is never going to be coming from these transmission environments. Yeah. So what kind of data is being generated? I hope we have a little bit of a better understanding of what SCADA traffic looks like, but like what are the types of things that it's being used to control? One of those things are compressor stations. So basically, every 50 to 100 miles on natural gas pipelines, there are compressor stations that basically filter the gas, recompress it, and cool it down. It just helps with the efficiency of those systems. So in every 50 to 100 miles, there's basically, a remote site that is going to be doing those functions. And so there are, both commands that need to be sent to those, as well as maintenance data or other data that's coming back from how those systems are operating. So that's like one of the big reasons why they use remote connectivity. And then the other really big one are kind of the interconnect points. So as the data is coming from the transmission companies down to the distribution companies, the interconnect point is, how when company X buys from company Y, like that valve there is physically diverting how much they buy, how much gas they buy. So in theory, an interconnect point is actually a much more exciting target to an adversary, because if you are able to compromise how that valve is working, then you can potentially turn off gas to any of the downstream customers. And then, so that's the kind of data that's being generated. We really need to talk about like how's that data at risk. So like what means if commands are being spoofed? What means if you don't have, if you can't see, or if you don't have control over those environments, but maybe they'll still work, like with the wind turbines? What happens if you can't see them or control them? And then the other really important part here is, are these primary or secondary comms pathways? Like luckily, because critical infrastructure often knows that they're important, they do have a lot of redundancy built in. So when we were talking to a lot of the end users of this service provider, it kind of varied by just how their business contract worked out. Like, were these satellite communications being used as just backups, or were they primary? And there was a mix of both. When we talk about like impact to control process, so like what are the impacts from the different commands that are being sent versus impact to the physical impacts to the system, I think a really helpful tool to kind of generate those ideas is the ICS attack framework from MITRE. So this is kind of like the last three columns of that, and I think the first two columns kind of talk about like what is the impact to the logic controller, and then the last column is kind of like what is the impact to the system as a whole. Okay, I'm out of time, but I'm gonna go really quickly. Conclusions, when we talk about mitigations, I'm gonna say I don't really know about mitigations because I like to do threat analysis, not mitigations. But there was a lot of fanfare from this NSA cybersecurity advisor that came out a couple weeks ago, or months ago now. I think it's a really good starting point, but you can tell that it was really inspired by military applications of satellite communications. It doesn't really go into the nuances of other applications. Like one of the biggest things is it basically just says like, encrypt your systems, or excuse me, encrypt your data links. And like, they're not wrong, but also when we're talking about real-time operations, like you often can't just add like transect to that. Like that's going to mess up the timing. So I think we can't just like, keep telling people to read this. We need to like think a little bit more harder about these systems. And then there was just other common sense like patch your systems in that CSA. I think like the biggest mitigation that I took away from this experience is that, and the customers that or the end users of that SATCOM provider, the biggest thing that we really were informing them was that there was a lot of risk they did not know in the systems that they had implemented. So we just really need to continue to tell them that you can't treat your third-party communication pathways as trusted. Like you have to think about it like public internet. Like even if it's a private data stream, it's really not private. So final thoughts, systems are complicated. Let's kind of go consequent-driven in our analysis. Like let's not just stop at where the IT part stops. Like let's go all the way down to the physical process. And then like what drives change? Like when I was doing some of the research for this talk, I found like a document from 2006 that basically said everything that I'm saying. So like obviously what we're doing isn't working, and I think we need to stop getting spun up about like ICS and like actually talk about like how can we protect these systems from an engineering perspective. Okay, that's it. Thank you. What questions do you have for me?
That was amazing. Thank you very much. A speaker gift for you. Any questions for MJ? Over here, Alex, quickly. Where is it?
Sure.
So basically it's mindset when it works, don't touch it. So how does CISA move from that mindset and what are the steps to actually change that?
Yeah, I think that's a really good question.
Can you repeat the question just a little?
Yeah, sorry. Basically, I think your question was like, how do we move past telling people not to touch their systems? Amazing. I think, and I come from a cyber background, not a engineering background, and I think the first thing that I think we have to do is basically education, which is kind of what I'm trying to do here, and like make it seem less scary and like actually give people like the understanding of the different pieces so that then we can have a conversation. But honestly, I don't know what to say.
I agree with you.
Yeah.
So I think you're absolutely right, and educating industry is very important step, but education without enforcement later doesn't work.
Sure.
It's like security development life cycle. You can teach the developers how to write the secure code, but if it's no enforcement, it will be tons of bugs.
Yeah, I think what I really meant wasn't educating the industry, but it was educating like people in cybersecurity so that they can stop thinking of it as something other and then kind of move forward like we have with other cyber problems, if that makes sense. But it's hard.
Thank you. Another big round of applause for MJ.